Now the work done in adiabatic process. Here, let the initial temperature, pressure and volume be P1, V1 and T1, and finally after the work is done it becomes P2, V2 and T2. Okay, work done by gas is given by W is equal to PdV. We have seen it previously, and the gas expands from V1 to V2. Till that time the work is being done, okay, which is given by PdV. Now as it is an adiabatic process and hence Poisson's law will be applicable. In the very beginning we had seen that for isothermal Boyle's law was being followed, and for adiabatic process Poisson's equation or Poisson's law was being followed. So Poisson's equation is PV gamma is equal to K, and so P is taken upon K upon V gamma, and when you bring this up it is becoming K V inverse of gamma. Now keeping the value of P from this equation here, so we are having W is equal to V1 lower limit and V2 upper limit, K V minus gamma dV. Now I have already explained you and sent you a video of integration differentiation. I am not going to explain it again and again. I'm just applying the integration here. Finally for the integration you are getting this value V minus gamma plus 1 minus gamma plus 1 with the upper and lower limits. Finally K 1 minus gamma we are bringing it out. Here minus gamma plus 1 tha, we are writing it as 1 minus gamma here. And V2 1 minus gamma minus V1 1 minus gamma, and then we proceed further. So when we proceed from the previous equation, we are bringing K inside. Okay, final equation here was K upon 1 minus gamma, V2 1 minus gamma minus V1 1 minus gamma. We bring K inside and we are multiplying it both the sides, right? Now, initially we had seen that P1 V1 gamma is equal to P2 V2 gamma was a constant. So this K can be replaced by any of these two values, and for here we are replacing it by P2 V2 gamma and V2 1 minus gamma. Here we are replacing it by P1 V1 gamma, V1 1 minus gamma. Okay, so gamma gets cancelled out and here we are left with P2 V2 minus P1 V1. Okay, so now 1 minus gamma yahan tha. If we are changing the sign, we are bringing P1 V1 here minus P2 V2, and similarly we are changing the sign gamma minus 1. So minus minus gets cancelled out and the first equation for work we are getting as this. Okay, these equations are important. We'll be seeing the numericals also. Then what we do is, the other equation can be written as, we know P1 V1 is equal to mu RT1. Okay, PV is equal to mu RT hota. So here we are taking as P1 V1 is equal to mu RT1 and P2 V2 as mu RT2. And substituting these values here, instead of P1 V1 we are writing mu RT1 minus mu RT2. I have just taken out mu R as common and we are writing T1 minus T2. And gamma minus 1 is already there. So you get two equations of work in the case of adiabatic. Work done on adiabatic, you can say in the adiabatic process. Work done on the gas in the adiabatic process. So there are two formulas for work which you can go through. I would like to tell you that you better do these derivations. The derivation for work, the derivation for the curve of isothermal and adiabatic process. These derivations are important and we asked in the questions, the exams also.